So, Avi Loeb just released brand new data about 3I Atlas, and once again, it's doing something that challenges everything we thought we knew. The object, this mysterious interstellar traveler, has just emitted its first ever detected radio signal. And within hours, the entire scientific community and the internet went into complete meltdown. For months, astronomers have been trying to catch a whisper from this thing. They've been listening, scanning, hoping. They tried on September 20th, nothing. Then again on September 28th, still nothing. But then on October 24th, just 5 days before its perihelion, its closest approach to the Sun, everything changed. At that moment, 3I Atlas was roughly 1.5 astronomical units from the Sun. And then, the signal came through. The radio telescope array in South Africa, Meerkat, picked up two very specific frequencies, 1.665 GHz and 1.667 GHz. Now, if you're not familiar with radio astronomy, here's why that's jaw-dropping. Those two frequencies are like a cosmic fingerprint. They're not random static or interference. They correspond to the exact absorption bands of one specific molecule in the universe. It's like discovering a barcode that can only belong to one item in the entire cosmos. And that's where things start to get weird. Remember Avi Loeb's earlier calculations? He showed that 3I Atlas came from almost exactly the same direction as the famous WOW signal detected back in 1977, the one many still believe might have been a genuine alien transmission. That signal, the WOW signal, was recorded at 1.42 GHz, a frequency that just so happens to correspond to the hydrogen line, the most abundant element in the universe. Now, these new signals from 3I Atlas, they're at 1.66 GHz. Not identical, but strikingly close. Close enough to make scientists pause. Close enough to make skeptics uncomfortable. So, is this just another cosmic coincidence? Or is there something deeper, something deliberate behind these frequencies? To understand what's going on, we need to look at what Meerkat actually detected. It didn't hear a broadcast. It saw a shadow. Meerkat observed 3I Atlas blocking certain radio waves coming from deep space. When sunlight, or in this case, solar radiation, strikes ice, it breaks apart the water molecules. This creates something known as O-radicals, fragments of oxygen that absorb radio waves at very specific wavelengths. Meerkat picked up those exact wavelengths. In other words, it caught 3I Atlas blocking cosmic radio energy in a pattern that perfectly matches what you'd expect if its surface was releasing O-radicals, tiny molecular ghosts of evaporating water ice. The timing is suspiciously perfect. The detection came just 5 days before perihelion, when the object was being blasted by intense solar radiation. At that distance, scientists estimate the surface temperature was around 230 Kelvin, or minus 40 degrees Celsius. Freezing cold by human standards, sure, but warm enough for ice to start sublimating when you're that close to the sun. So far, so normal, right? Ice heats up, ice vaporizes, vapor turns into radicals. Radicals absorb radio waves. That's exactly what comets do all the time. So, case closed. Just a comet doing comet things. Or is it? Because here's the problem that refuses to go away. If 3I Atlas is really a natural comet, and if this sublimation is what's driving its non-gravitational acceleration, then where is the gas? Where is the massive cloud it should be leaving behind? Avi Loeb and others calculated that 3I Atlas should have lost at least 1/6 of its total mass during perihelion. That's around 5.5 billion tons of gas and dust, enough to create a massive, unmistakable coma or tail visible from multiple observatories. But that's not what we're seeing. Post-perihelion images show a compact, intact object. Sure, there's a faint halo around it, but nothing like the spectacular tails typical of comets shedding billions of tons of material. So what's going on? Either the gas is somehow invisible to our instruments, hidden in a form we're not detecting, or the acceleration isn't from outgassing at all. Now, that's where things start to tilt into mystery, because the O-radical detection confirms there's some sublimation happening. But the amount? That's the missing piece. A small layer of ice vaporizing off the surface could easily explain the O-radicals, but it can't explain the measurable push the object is showing, an acceleration too strong for the observed loss of mass. That's what makes 3I Atlas so puzzling. It's behaving partly like a comet, but also partly like something engineered. And this isn't the first time we've seen this pattern. Remember Oumuamua back in 2017? The same non-gravitational acceleration, the same lack of visible tail, the same debate between natural object and possible technology. Could 3I Atlas be another one of those, or even related? Back to the data. Loeb pointed out something else that's difficult to ignore. When the WOW signal was detected in August 1977, 3I Atlas, based on its current trajectory, would have been about 600 times farther from the Sun than Earth. And it was coming from almost the same spot in the sky. The arrival directions matched within 9 degrees. The probability of that being random? Just 0.6%. That's not impossible, but it's statistically suspicious. So, Loeb contacted observatories all over the world, urging them to specifically monitor 3I Atlas for radioactivity. And now, here we are, with the first radio absorption detection ever recorded from this mysterious traveler. But the search is far from over, because on March 16th, something extraordinary is going to happen. 3I Atlas will pass within 53 million kilometers of Jupiter, an incredibly close approach. And guess who's already there? NASA's Juno spacecraft, orbiting Jupiter, equipped with an advanced dipole antenna capable of detecting low-frequency radio emissions. When that moment comes, Juno will listen. If 3I Atlas emits anything, any pattern, any anomaly, any signal, Juno will hear it. That single observation could change everything we know about this object. So, the question is, are we on the verge of discovering the most peculiar natural comet ever found? Or are we finally brushing up against something artificial? The next few months will decide. And trust me, you're going to want to be here when the next data drops. Because if that signal turns out not to be random, if Juno hears something that matches Meerkat's detection, then this won't just be another comet story. It'll be one of the greatest mysteries in the history of astronomy. Are we looking at nature's weirdest creation, or a messenger from somewhere else? As the clock ticks toward March 16th, the world of astronomy is holding its breath. Because that's the day 3I Atlas will make its closest approach to Jupiter, a once-in-a-lifetime opportunity to uncover the truth about what this object really is. At that moment, NASA's Juno spacecraft will be in perfect position, its powerful antenna ready to listen for anything unusual. If 3I Atlas emits any low-frequency radio waves, even faintly, Juno will detect them. And that detection could redefine how we view interstellar visitors forever. Now, let's take a step back. Because before the signal, before the hype, 3I Atlas already had scientists scratching their heads. This thing entered our solar system moving at astonishing speed, faster than any known comet of similar size. Its trajectory, hyperbolic and precise, indicated it wasn't bound to the Sun at all. It came from somewhere beyond, from deep interstellar space, and it's leaving just as mysteriously as it arrived. But then came the weirdest part, the acceleration. Objects moving under pure gravity follow a predictable path. Yet 3I Atlas refused to obey. As it passed near the Sun, it subtly but measurably sped up, as though pushed by some invisible hand. Scientists first thought it might be outgassing, jets of vapor shooting from its surface, nudging it forward. But the math didn't add up. There simply wasn't enough visible material to produce the acceleration we were observing. So, if not outgassing, then what? That's the question that made Avi Loeb step into the picture again. Loeb, never one to shy away from bold ideas, suggested something radical. What if 3I Atlas isn't a natural body at all? What if it's a piece of technology? Something like a light sail, an ancient probe, or a fragment of interstellar machinery drifting through our cosmic neighborhood. It sounds unbelievable until you look at the data, the smooth acceleration curve, the lack of a visible tail, the exact direction it came from, nearly identical to the WOW signal of 1977. And now, the radio absorption signature detected by Meerkat. It's as if every new observation opens another door instead of closing one. But before we jump to conclusions, let's talk about what's coming next. Juno's mission is primarily focused on Jupiter's atmosphere and magnetic field, but its instruments are sensitive enough to detect radio emissions from beyond. In fact, Juno regularly picks up bursts of natural radio waves from Io, one of Jupiter's moons, caused by plasma interactions. So, if 3I Atlas emits anything, artificial or natural, Juno will hear it. And when that happens, we'll have data no Earth-based telescope could possibly match. Scientists plan to compare whatever Juno hears with Meerkat's earlier detections. If the frequencies line up, or if a modulation pattern appears that doesn't match known natural sources, then it's game over. That would mean something is deliberately transmitting. And if it is, who or what is it transmitting to? Now here's where the story gets even more intriguing. The WOW signal of 1977. A mysterious radio transmission that lasted exactly 72 seconds, detected by Ohio State University's Big Ear Telescope. It came from a point in Sagittarius and was never heard again. Fast forward to today, and 3I Atlas arrives from almost the exact same region of the sky. The odds of that being pure coincidence? Less than 1%. So now, when Meerkat detects signals near that same range, 1.66 gigahertz, not far from the 1.42 gigahertz of the WOW signal. It feels like history repeating itself, but this time we're watching it happen in real time. So what happens next? When 3I Atlas swings past Jupiter, astronomers expect gravitational forces to subtly bend its path. That will give scientists a chance to study how it reacts, whether its motion follows the laws of gravity precisely, or whether there's still that same mysterious acceleration. If the anomaly continues, it will confirm beyond doubt that something non-natural is at play. And if Juno's instruments detect even the faintest repeating pulse, something with structure, rhythm, or encoded modulation, then humanity's first confirmed contact with interstellar technology won't be a sci-fi dream anymore. It'll be a scientific reality. But even if that doesn't happen, even if 3I Atlas turns out to be nothing more than a bizarrely behaving comet, it still changes everything. Because it means our solar system is full of visitors carrying secrets from beyond. Each one, Oumuamua, Borisov, and now 3I Atlas, teaches us something new about how material travels between the stars. And if even one of them turns out to be artificial, then it means we are not alone, and haven't been for a very long time. Until March on 16th, all we can do is wait. The telescopes are pointed, the antennas are listening, and the world is watching. So as the data starts coming in this December, keep your eyes on the night sky. Because the answers we've been searching for might already be on their way. Do you think this is just a natural comet behaving strangely? Or are we witnessing the first real evidence of something engineered? A message, a relic, or a probe from another world? Either way, one thing is certain. The universe just got a whole lot more interesting.